All right, this is our video lesson about roots of a quadratic. Um, so the design for this lesson is that you do number one, we solve for x, where 0 is equal to x squared minus 2x minus 3. And it's a quadratic because you have your it's a quadratic equation rather, because you have your x squared term. So you have to make sure it's set equal to 0, which it is. So now I can solve this thing by factoring. And I'll use IM factoring to do it. Excuse me. So I want to figure out what number, if I write my little IM in here, what number times what number equals -3, and simultaneously those numbers have to add up to -2. And if you think for a moment, the answer to that question is -3 and +1. So my factors are going to be x minus 3, whoops, let me write that again, 0 equals x minus 3 times x plus 1. And then I can factor this thing, or set each factor equal to 0, rather, to get the solutions to the equation. Add 3 to both sides, x equals 3. Subtract 1 on both sides, x equals -1. And there are my answers. For number 2, I want you to graph y equals x squared minus 2x minus 3. So notice the difference. I was solving an equation where 0 was equal to x squared minus 2x minus 3. And now I want you to graph y equals x squared minus 2x minus 3. So let me clear everything that's in here. So we will graph. So to do this, we did this yesterday. You just, if you're on the main screen here, you press y equals, and you're going to type in x squared minus 2x minus 3, and you go second graph, which gives you a table. And we said yesterday that the table has to have the same y value, top and bottom. It has to be symmetric, basically. And as you notice, I have currently -3 on the top and +21 on the bottom. So I'm going to scroll. And if I scroll, now I got 2 zeros. That's good. But I still have a 12 in the bottom. And now, lo and behold, there's my table. And this is the perfect table for us to graph. Okay? So there is our table. And notice I need both negative x's and positive x's. And I need both negative y's and positive y's. So I'm going to put my axes pretty much in the middle, making sure I have enough room to get up to x equals 4. So I think I'll offset them a little bit. I'll put my y-axis here, just so I have a little more positive room than negative room. And my y-axis I'll put in the middle of the page, like so. So here's x, here's y. And we're counting by 1, so I won't even bother to label the grid. So I have -2, 5. 1, 2, 3, 4, 5. There it is. -1, 0, which is right here. 0, -3. 1, -4. 2, -3. 3, 0. And 4, 5. And here is the parabola. Okay. And the coordinates of the vertex is here, so the coordinates of that vertex are 1, -4. And that vertex is in the middle of our table of values. And by the way, if you're doing this, obviously you're doing this on paper, you should copy down the table. Copying down the table is the work for getting the numbers for the parabola. So here's my vertex. Is the vertex a min or a max? I think it's pretty obvious. It's a minimum. But remember, if the x squared is a positive version of x squared, you will always have a minimum. And if it's negative, you always have a maximum. The equation of the axis of symmetry is just x, the axis, x equals 1. And if you want to see that on the graph, the axis of symmetry is here. Slices the graph into 2 equal pieces. And that's cutting the x axis, the x, at 1. So x is equal to 1. Now, I want you to pause the video and take a look. And I want you to see if there's a connection between your answers in question 1 and this graph, the graph of the parabola. So are these answers in question 1, are they represented somewhere on the graph? And if so, where are they represented on the graph? So pause the video and try to answer that question for yourself in your mind. How are the answers in question 1 represented on the graph in question 2? Well, I hope that you saw, after you pause, that the answer is that, well, x equals 3 is, let me do this in a different color. X equals 3, this root, I'll do it in purple, is right here. And x equals -1 is right here. And notice, they're both where the graph intersects the x-axis. And these are called roots. So the roots of the quadratic are x equals 3 and x equals -1. And roots, so a root has two definitions. One is that it's the solution to an equation. So x equals 3 and x equals -1 are called roots. On the graph, they are what we can call the x-intercepts, meaning where the x-axis intersects the graph, or where the graph intersects the x-axis. So now to fill in our blanks, it says the graph of the quadratic shows the roots where the parabola intersects, or meets, intersects is just a fancy word for meets, the x-axis. And from there, I believe you would be able to answer all of the questions on roots, now that you know what they are. So roots are the solutions to the equation. I'll put solutions plural in here. And they're also represented on the graph by the x-intercepts, by the 2 points where the graph meets the x-axis.